Hello, my name is Barshal. I'm a program manager with the Visual Studio Azure Tools team, and I'm here today to talk about the diagnostics tooling improvements we've done in Visual Studio and the Windows Azure SDK 2.2. Let's get started. I have a very simple cloud application here, which consists of three tiers. It's a front-end tier, a processing tier, and then it stores the data in SQL storage, in Azure storage. So just to give you an idea what the application does, I'm going to give you a little example, and I'm going to run at 5. And so that will launch the emulator for a local debugging experience. And then once the website is up and running, the application that I build, which is my sample application throughout the demo, is basically a very simple thumbnail generator. So what it does is I actually can browse, I can select an image here. So for example, I can select an image of Real Madrid, and then I just upload it. And what's happening in the background is the image itself gets stored into Azure storage, and then we're going to put a message into an Azure queue, and the worker role picks up that message and basically creates a thumbnail of that image. So it's a multi-layered architecture application. So as you've seen, I'm uploading the image, and I'm hitting a breakpoint. Let's go through it just to show you the result. And I'm getting a message sent to the queue. So what we've actually done here is what I've described. If I go to storage node and see my development storage and go to blobs. So as you can see, the application has done exactly what we expected. It added the Real Madrid image to the blob container, and it also created a thumbnail. So the first thing I want to show you today is how you can use the new functionality, Edit and Continue, which we light up in Visual Studio 2013 with the SDK 2.2. We light it up for web roles and worker roles. For web roles, you really need to make sure you're not running W3 WP. So as long as you're using IIS Express, you're fine. So let's look at how it looks like. And I'm going to launch it again, the application in debug mode. And I'm actually using IIS Express on my local site to render that page. All right, so let's pick another image. Let's pick the image for FC Barcelona and upload and hit upload. So as you've noticed, on the worker role itself, I actually set a breakpoint, and the breakpoint is hit. But now, as you've seen before, I'm uploading it to a folder. It's actually called Glob Thumbnails. Let's say I want to make it like country specific, right? So in that particular case, I want to say ESPN for Spain Club Thumbnails. And that's pretty cool because I'm actually in debugging mode, and I can change like code, I can change information in there, and then I just can keep going and continue debugging through my application. And then if I just hit F5 to do a full continue, see message has been sent to the queue. And if I go back to Visual Studio and go to my blob storage container, I can see the changes have been applied. So this is really a huge improvement we ship with the Azure SDK 2.2. It's Edit and Continue. So in a development lifecycle, let's say I've done my local debugging, my local development. Now I'm at a point where I really want to push it out to Azure because I'm using the local emulators. So I want to do my real first integration test. The next feature I want to show you that we added to the troubleshooting options is actually the remote debugger. So for that, I'm going to go to the Windows Azure Publish dialog. Nothing has changed. I'm going to select my subscription. I'm going to hit Next, and then I'm going to go to Advanced Settings. So as you can see in the advanced settings, we now have an additional option which says enable remote debugger for all roles. So what that actually does is it packages up MSVSmon along with a component that we need to communicate with the roles, adds it into the package, and then we can deploy it up to Azure. So I'm going to hit Next, and then I'm not going to, for the sake of time, I'm not hitting Publish. I already published the service. So let me switch over to the project that actually has the published service. So here is the service. As you can see, it's exactly the same code. It has the worker role, the front end, and processing tier. And the publish has been successful. If we look at the activity log, so I published it, everything works fine. So now let's try the application again. Let's go in here, go to SDK demo, go to my production slot and launch the application in browser. So this is the application, as you can see in the browser. This is the live application running on Azure as a cloud service. And let's do the same thing again. Pick an image. Let's take the Borussia Dortmund one and upload it. So message sent to the queue. As we've seen locally, now if I drill into my storage account, and the storage account that I'm using for my queuing service and for my blob storage, I should be able to actually see the images. Let's look at the storage account. I know I use the Visual Demo storage account for storing my images and also for the queuing service. If I go to the blob service here, I can see the images. But then I already have like a Bayern Munich image in there, Real Madrid. But what's really missing here is the thumbnails. So obviously something is really wrong in my service. So what I can do now is, let's analyze it from top to the bottom. So this is my website code that actually takes the image here, getting the image, and uploads the image to the blob. That was still working. As we've seen, the image is in the blob store, as in a blob container, and then we add it to the queue. So let's check if something goes wrong here. So what I can do now with the Azure SDK 2.2 in a cloud service, remember that we enabled remote debugging during publish. I can go in here and I can basically, on the role itself, I can say attach debugger. Also what I could do is, if I had more instances in the role, I could attach it to an individual instance. So for now, because I only have one instance here, I just choose attach remote debugger on the instance. So let's do that. So the debugger is attached, the breakpoint, the symbols are loaded, and now I can go in here and actually go to production slot again. Say view in browser, open up another session, use an image, and upload it. So now the breakpoint is hit, and I can see I'm actually uploading the image. That was as expected, and I can see I'm uploading it to visualdemo-blob.core.windows.net, which is actually the blob store. So what I can do now is I can step through it, and I get to the queue manager, and as you can see, which is pretty cool, you can use the debugger, the remote debugger, just as it was like a local debugger. The only difference is that I'm really debugging a cloud service. So that should enable you to really be able to troubleshooting running cloud services in a dev test environment. So let's hit next. So I'm not getting an error from the queue manager, which I know is adding the message to the queue, and not getting an error, and that's why I'm actually putting the message out there, message sent to queue. So let's go out there and see. So obviously something went wrong here. What I could do now is, as I've shown you, I can actually go back and I could attach the debugger to my worker role, because obviously there's something wrong in my worker role, right? Let's look at the worker role. Let's look at here. Set a breakpoint in the worker role and actually attach the debugger to the worker role. So breakpoint is hit, and as the worker role is running, I would expect going in here, launching the application again, selecting an image that actually uploads the image, puts a message into the queue, and I'm hitting the debugger again, which is pretty cool. So let's see what's happening here. So I'm getting a message from the queue manager, hitting F10 to see what's actually happening. All right, and as you can see, the code is not being executed. I'm actually ending up in the catch block, so I'm catching an exception here. And if I keep going, I actually see like the exception down here, which basically says the remote name could not be resolved. So it's trying to get the queue message from bshol demo2.queue. So apparently there has been a configuration mismatch when I was deploying that service to Azure. So in that demo, I really wanted to show you how powerful the remote debugging feature is, because it really gets you into a place where you can quickly analyze issues with your applications, and you can really see what's going on. And more so, you can use tools that are really familiar to you as a developer, which is the debugger. Okay, so let's stop that for a while and say you don't want to use a debugger, right? Because sometimes you have some, let's say you progress that application through a bunch of stages. Let's say that happened in your first integration cloud service, which is just a cloud service used by developers. But let's say now you're going to push it out to a production staging environment, for example. Obviously, you're really reluctant to set up a debugger in a production-like environment, or even in a production environment. So the question is, how would you actually catch the error there? So if I go back to Server Explorer and the processing tier, because in that demo I know it's happening there, I can see view diagnostics data, and I can actually get that command on every single instance or in every single role in a cloud service. So let's go in here and see what happens when I click view diagnostics data. So the view diagnostics data caught the errors. And I also can see the remote name could not be resolved. So again, even if you don't use the debugger, we put you in a state that when you use Windows Azure, when you use systems.diagnostics and put straight trace statements to your code, that we catch the errors. And let me show you how we do this, where the magic happens. Let's go back to the code and look at the code itself. So in the code itself, you can see we added some trace statements, as I would assume every developer does, right? So in the try and catch block, in the exception handler, I'm going to actually write an error with the message that contains the stack trace. So how does that show up in that view? So the way what we've done is, if we go to a role designer, which you can get to by clicking on that role, and if I scroll it, right, in the configuration tab, you can see enable diagnostics. And what we do by default is we have a configuration in there that allows you, or allows Azure Diagnostics to catch errors by default. So that means as long as you use trace.traceError, or you're going to raise any errors in your code, Visual Studio, the way the Visual Studio project is constructed, we will catch those errors. So you can also go in here if you wanted to change it and say, hey, I just want to get all information, not just errors, right? Or you can even go in here and say edit it, and you can add like many more things. So for example, in the application logs, you can set it to verbose. That's what I've just done. But you can also set like the verbose or the log level for event logs that are actually the event logs that are happening on the virtual machine that is hosting your instance. You can add perf counters, you can configure perf counters, you can configure the infrastructure logs, and you can do some configuration for crash dumps and IIS logs. So as you can see, by default, we set up the Visual Studio project in a way, a Visual Studio Cloud Service project in a way that as long as you use systems.diagnostics namespace and trace your errors, will set you up on a path to success that you basically be able to identify those errors right away. And you can do that by just going to a role and looking at the diagnostics data. So if we go back to that role and look at the context menu, we also have update diagnostic settings. So when that would be useful is, for example, right now, by default, we only catch the errors. And that's why the errors were showing in the summary page. But we could also say, hey, I also have some trace statements for trace information in there, right? I can go in here and can say, okay, I want to update the diagnostic settings for that particular role, or I can even do it on an instance level. And then the new settings get applied to it. So this was really just a very, very brief demo for cloud services, the tooling that we enabled for you in the Azure SDK 2.2. which is basically a very improved diagnostics experience from end to end, or from start to end. Sorry. Let's switch over because we're not done yet. So the remote debugging feature is a very cool feature. Now you might wonder, hey, I want to do that for infrastructure as a service. I want to debug virtual machines or applications on virtual machines, or I want to debug Azure websites. So let's look at the Azure websites debugging experience. All right, so as mentioned, we not only provide a remote debugging feature for cloud services, but we also provide it for websites. So the last demo I'm doing today is really showing you how to use the remote debugging service for Azure websites. So in that particular case here, I have a new application, which is fairly straightforward. If I have FiveIt here, it's basically just determining if the number you entered is a prime number or not, right? And so, as you can see in Server Explorer, the websites node, the website shows up here. And let's see if my calculation does actually make any sense. So, as with cloud services, I can set it up here. I didn't have to enable remote debugging during publishing. The Azure Website Service just provides remote debugging as a service. So there is no packaging experience. That's why I don't show you like the publishing of the website. So let's say the website is up and running. I can just go in here and basically say, okay, I want to attach a breakpoint. And then like the experience in cloud service, you can choose attach debugger. And when you do this, what's happening is actually it's reaching out to the remote debugging service for Azure websites, launching the website. All right, and then let's see if it works. Let's try 13. And at 13, I'm ending up in my method that is actually checking whether it's a prime number or not. And then just like with the local debugging or the remote debugging in a cloud service, I can just step through it and can inspect can debug my live running Azure website, which is pretty cool because I can take advantage of all the debugging features in here. Thanks for watching the demo, and I hope you enjoyed this as much as we building those tools, and we hope it's really useful for you. For more information, go to windowsazure.com and read up on Azure Diagnostics tooling.